All right. What we're starting today is Chapter 2. Now, Chapter 2 is going to be, again, like the last few chapters, revolving around sine, cosine, tangent, secant, cosecant, cotangent. And these are some of the identities that we have, and we've seen most of these already. Our sine is 1 over cosecant, cosine's 1 over secant, tangent's 1 over cotangent, cosecant's 1 over sine, secant's 1 over cosine, and cotangent's 1 over tangent. Our reciprocal identities. And we've used these before, especially converting from sine to cosecant or secant to cosine, going back and forth. Our quotient identity. Tangent's equal to sine over cosine. Cotangent's equal to cosine over sine. We've seen these before. And the most helpful ones out of all of these on the first page, especially for solving, are our Pythagorean identities. And we have these three here. Now, sine squared plus cosine squared equals 1 is one of the three forms that we can actually have it in. Because if we solve this equation for cosine, we actually get cosine of u is equal to 1 minus sine squared of u. So cosine squared of u is equal to 1 minus sine squared of u. Or, if we solved it for sine, we can say sine squared of u is equal to 1 minus cosine squared of u. So there's three different ways that we can have this equation, and it depends on which one we need to use. So it could be that we have cosine squared plus sine squared, well, we can replace it with 1. Or if we have 1 minus sine squared or 1 minus cosine squared, we can use one of these here to be able to get what we need. The same thing's true for our other two. 1 plus tangent squared of u is equal to secant squared of u. Or we can say tangent squared of u is equal to secant squared of u minus 1. Or that cotangent squared is equal to cosecant squared minus 1. And we have these here. Now we have our cofunction identities. Sine of pi over 2 minus u is equal to cosine of u. And the rest of these here, really pi over 2 again is the same as 90 degrees. So we're really saying sine of 90 minus theta is equal to cosine of theta. We have these here. We also have our even and odd functions. That sine of negative u is equal to negative sine of u. And cosine of negative u is equal to negative cosine of u. That is not right. Because cosine is an even function. Because it should be cosine of negative u is equal to cosine of u. I believe on that sheet there, yep. Cosine of negative theta is equal to cosine of theta. The reason we can say that is because cosine is an even function. It's like our quadratics. It's also the same as saying, so x squared is considered even. So 2 squared is equal to 4. Well, negative 2 squared is still 4. We get the same value. It's an even function. So those two should be the same, and I believe our reference sheet I gave you this morning does agree with that. I don't know why this here had it, and it's probably something that I need to make sure to fix. Because cosine and secant are even. The rest are odd. Find the values of secant. Find the values. Secant of u equals negative 3/2, and tangent of u is greater than 0. To find all values of, to find the values of all 6 trigonometric functions. So we need to find all 6. Well, really we're finding 5. Because out of all of them, sine of u, cosine of u, tangent of u, secant of u, cosecant of u, and cotangent of u. We do have 6 trigonometric functions we need to find the value for. But they told us secant is -3/2. They just told us that from the beginning. Well, we know one of the others already. Because according to our reciprocal identity, secant of u is equal to 1 over cosine of u. So it's our flip. So if secant of u is -3/2, cosine of u is -2/3. So if we're given sine, we also have cosecant. If we're given cosine, we have secant. If we're given tangent, we have cotangent, and vice versa. So whenever we're given the value of one of the 6 trig functions, we really have the other because of our reciprocal identities. But we still need to find the rest. Now, there's different ways we can get at the rest of them from here. One of them, so secant, leave it on. I could use this formula to find tangent. So I'm going to write this in the middle here. Yeah. Because we were saying that secant squared of u is equal to 1 plus tangent squared of u. And we know whatever value tangent is, it has to be positive, because tangent of u is greater than 0. Now, secant squared, or secant of u, is -3/2. So we're saying -3/2 squared is equal to 1 plus tangent squared. Well, -3/2 squared is 9/4. Because -3/2 times -3/2, the negative times the negative would be positive. We'd multiply the numerators. 3 and 3 is 9. The denominators 2 and 2 is 4, giving us 9/4 is equal to 1 plus tangent squared of u. Now we're solving for tangent, so we do need to get it by itself. We would start by subtracting 1, telling us tangent squared of u is equal to 5/4. And we could have done that in the calculator. 9/4 minus 1 is 5/4. Now the last thing we need to do in solving this here is take the square root of both sides, which would give us tangent of u is equal to plus or minus. We need to take the square root of 5/4. Can we take the square root of 5 and get a nice number? No, square root of 5. Can we take the square root of 4? Square root of 4 is 2. So by pure mathematical solving, we would get tangent of u is equal to plus or minus the square root of 5/2. But in the original problem, it told us tangent of u has to be greater than 0, has to be positive. So it's just going to be positive. Square root of 5/2. Well, that does tell us cotangent, because cotangent's 1 over tangent, so we're flipping it. So our cotangent of u would be 2 over the square root of 5. Now it might seem odd I'm writing this under tangent and not just putting it over in part of our answer, but the denominator for cotangent right now is irrational. We have a square root. And if we rationalize it, we can plug it into the 30xs or do it by hand. We get 2 square roots of 5 over 5 we get this here. Now that leaves us with sine and cosecant. Now there's two ways we can get at this. One is, well, I'm going to do this on the next one. You can write it down below. If you didn't draw that in, that's fine. You can write it out to the side. Still on the previous, yeah. There's two ways we can go about this, and really it's going to come back to our Pythagorean identities for the most part. Because we know what cosine is already. So I could use the fact that sine squared is equal to 1 minus cosine squared. Or we can use the fact that 1 plus cotangent squared is equal to cosecant squared. We can use either one of these here. So I'm going to use sine squared of u is equal to cosine squared of u sine squared of u is equal to 1 minus cosine squared of u. I had it flipped. And we can use this here. And the reason we can use this is because I know that cosine is negative 2/3. So we can plug it in. Two-thirds squared is 4/9. Square root both sides. We get sine of u is equal to plus or minus square root of 5 over 3. It's actually not, funny enough. And I'll explain that here in a second. But I think we're both caught up, yes? Now, it is tempting to say that this is going to be positive, but we said tangent was positive. The only way tangent can be positive is if sine and cosine are both positive or both negative. And since cosine is negative, sine has to be negative. So for us here, sine of u is negative square root 5 over 3. And for the last one, cosecant, we have to flip this. Well, we could write it out, or I can just grab the calculator, say negative 3 over second square root of 5, and get negative 3 square roots of 5 over 5. And we have all 6. Questions on these here? We feel good with these here so far. There is, I think, a little bit easier way, because this works. Using the formulas works. It will work every time. We do have to be careful with signs, especially with sine. Pun not intended there. But I think there's an easier way to do it. And it's not that this is wrong. I just like triangles. Because if you remember last year, for the most part, if we're trying to find a lot of the trig and they give us a value and telling us one of the others is positive or negative, I very much revert back to triangles, and especially in a coordinate plane. I put it in a coordinate plane because it helps us figure out signs. Which one's positive, which one's negative. Now they tell us tangent of u is 1/3. Okay. And they also tell us cosine of x is less than 0. Cosine is really telling us cosine is what? Cosine is negative, yes? And is cosine dealing with our x or y? And this is going really back to the unit circle. Cosine, so cosine of x is what? Adjacent over the hypotenuse. So adjacent, if we think of this as the center, and I'm just going to draw this triangle, don't draw this one yet. And I said this was our angle with the x-axis, so with this side, or this side of the triangle be the adjacent side. Would it be the blue or green? One more time. Blue. Because adjacent would be next to it, so next to this angle here would be our blue. And it works out that cosine is actually kind of our x. And again, I always refer back to the unit circle, especially. I'm not making y'all memorize these. Quadrant 1, sine, cosine, and tangent are all positive. Quadrant 2, sine, cosine. Sine is positive. Cosine and tangent are negative. Quadrant 3, sine and cosine are negative, but tangent's positive. And in quadrant 4, sine and tangent are negative, but cosine is positive. So, well, this is telling us that cosine has to be, and this is telling us that tangent has to be. So out of the 4 quadrants, we're in quadrant 3. So over here, I draw my triangle to set this up. Now it doesn't tell us anything about cosine other than the fact that it's going to be negative. So we're finding sine of u, cosine of u, tangent of u. Cosecant of u, secant of u, and cotangent of u. And the only one we know for sure is, well, not technically. We know tangent's 1/3. So what's cotangent? 3 over 1, or just 3. Now we can go back to our formulas and plug them in from there. But tangent is what? Opposite over adjacent. So what it's telling us for this here, the opposite side is 1. The adjacent side is 3. I have a triangle, yes? And specifically for this here, and with sine, cosine, tangent, it's going to be a right triangle. So Pythagorean's theorem, a squared plus b squared is equal to c squared. We're saying a in this case is 1, b is 3. Really, it doesn't matter which one we call a or b, we would get the same thing. Well, 1 squared is 1, 3 squared is 9, c squared. So we're saying c squared is equal to 10. C is equal to square root of 10. Now we normally would put the plus or minus when we're solving, but because we're talking about Pythagorean's theorem, we're talking about the hypotenuse. The hypotenuse is always positive. Square root of 10. But we do have to make one minor adjustment to this triangle. And it's actually still referring to sides, because hypotenuse, this r value is going to be positive. Are we in the positive or negative x-axis? Negative, so okay. So that needs to be negative. How about the y-axis? That's another reason I like putting it on the coordinate plane, is I can see, okay, tangent, cosine, we're here. I'm on the negative x-axis, negative y-axis. I have those signs taken care of. Questions on how we set this up so far? So, in accordance to this triangle, with sine is what? Opposite over the, so the opposite side of our angle is -1. Our hypotenuse is, now we can plug this into the calculator and say -1 over second square root 10 is negative square root 10 over 10. We have the first one. Cosine is adjacent over the hypotenuse. The adjacent side would be -3 over the square root of 10. And if we plug that into the calculator, we'd get -3 square roots of 10 over 10. Cosecants, 1 over sine. Negative square root of 10 over 1, which is just negative square root of 10. Because we could use the other one, the negative square root of 10 over 10, flip it, which would be -10 over second square root of 10, which actually just works out to be negative square root of 10. And for the most part, when I flip it, I look back at this here. So -3 over the square root of 10, flip it, still negative, square root of 10 is on top, 3 is on bottom. And that's it. Questions on this here? Because, I mean, we didn't necessarily have to do this way. Because we also know that, because if we go back here, 1 plus tangent squared is equal to secant squared. So 1 plus secant squared. Well, I know what tangent squared is. Tangent squared is 1/3. So we have 1 plus 1/9 is equal to secant squared. Now we could do that 1 plus 1/9 by hand. Doing a calculator is 10/9. So we're saying secant squared of u is equal to 10/9. Square root both sides. So secant of u because we can't take the square root of 10, but the square root of 9 is 3, and we have the plus or minus. Well, secant, 1 over cosine, since cosine's a negative, secant has to be negative also. So we get this here. Well, we got the same answer from the triangle, yes? But that also begs the question, could we have done the first one through the triangle? Yes. Because if we looked at this here, and that's really where I was going to start before I changed plans. For tangent to be positive and secant to be negative, we're again down here in the third quadrant. Secant of u, well, really, as we saw already, told us cosine of u is -2/3. Adjacent, -2 over the hypotenuse is 3. We know because we're in the third quadrant that the x-axis is negative, so the negative goes with that side. And the hypotenuse is 3. Now, Pythagorean theorem, a squared plus b squared equals c squared. Well, c is going to be 3 squared. And we could say b is our -2. We could put it in as -2 or +2. It doesn't matter because, well, -2 squared is 4. Get away from the eraser. Next step would be to subtract 4 from both sides, telling us a squared is 5. Square root both sides, a is plus or minus square root of 5. Now, when we did this in geometry, we just said it was positive because we're talking about a triangle. But in this context, the opposite side would indeed be the square root of 5. Is the y value for that side, that distance we're going down, positive or negative? Negative, so it's -5. And I realize I don't think I actually said this last year, but really what we just found is this point out here, -2, negative square root of 5. From the last chapter where we were given the point and had to find the 6 trigonometric functions, essentially that's what we did. We set that up, then we can use it to solve the rest. Both work. Questions on this here? Okay. Now, most of the rest of this is going to be dealing with these reference pages. Now, I gave you reference pages today. Most of the stuff on the reference pages, we're not going to talk about yet. So on page 1, where it actually says reference page, the very bottom set of 3 equations, we're going to look at all of those except for those and the rest of it. So reciprocal and quotient identities, Pythagorean identities, cofunctions, odd and even are what we'll be mainly using today. Now, here, we want to simplify it. We want to write it in a simpler form if possible. And there's different ways to do that, and this might seem kind of a weird thing to do. Is there something in common with both terms? They both have sign. So what I can do is I can factor sign out. Okay, so we got sine of x equals, or sine of x times cosine squared of x minus 1. Now this part should look familiar. Do that. Pythagorean, yes? And actually, incidentally, the one that the arrow is pointing to does look similar to what we have, because we said sine squared of u is equal to 1 minus cosine squared. So here it'd be sine squared of x is equal to 1 minus let's get a highlighter. Are these two the exact same? Almost. They're close, yes? Because the one in the equation we're simplifying, we have cosine being positive and the one being negative. In the other, we have the one being positive and the cosine being negative. Well, what is one way I can just flip both sides? There's a way to do it. I'm going to multiply this by -1. If I do it to one side, I have to do it to the other. Because our -1 times cosine squared, negative cosine squared, makes the cosine positive. Our +1 times -1 makes it -1. But instead of positive sine squared, we now have negative sine squared. Because we have those the same now, I know that cosine squared of x minus 1 is the same thing as negative sine squared of x. We can replace it. Now over here, we have sine squared of x times negative, or sine of x times negative sine squared. Well, we can actually multiply these. We'd have negative sine cubed of x. So in essence, we have simplified it. This is a little bit simpler than what we started with. Our sine times sine of x times cosine squared of x minus sine of x. But it is a little weird. Yes. And one of the students last year definitely referred to this as mathematical cheating. It feels like we're cheating in some ways. Because up to this point, we've never used formulas in this way, where we've manipulated them and rewrote them. Really just manipulated them until we got them in a form that we like, and then plugged it in. Cosine of squared of x times cosecant of x minus cosecant of x. Well, cosecant is the same as 1 over sine, yes? So we can factor the cosecant of x out. And we'll get to how this works in a minute, but we can pull cosecant out because it's in common in both. Which does give us this here. Because we're trying to find ways to simplify it. And the fact that we do have cosine squared is helpful. Getting it with especially 1 being added to it, or really mainly subtracted from it. Either we have 1 minus cosine squared of x or cosine squared of x minus 1. If we can get it in one of those two forms, it is helpful. Because our cosine squared of x minus 1, we had it from the last problem, it's telling that this is the same as negative sine squared of x. Now we would agree that this does look simpler than what we started with, yes? We can make it simpler even. We can take it even a step further, because cosecant of x is the same as 1 over sine of x. And if we multiply these together, we get negative sine squared of x over sine of x. That seems like an odd way to simplify, yes? Think of it this way. X squared divided by x would be sine squared over sine. Simplifies the sign. We have 1 on bottom, we have 2 on top. One of them will simplify out. We're left with just this. Questions on this here? How do we feel about these so far? They're not bad, but they are weird. Yes. We will save this next part for tomorrow.